ebalwa ngezilokotho ezinhle Ithala kanye neGo Digital SA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology, kanye namaklasi e-learner wellness, okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu, kuqala ngehora lesi-4 kuya kwelesihlanu, u-4 kuya ku-5 ntambama, nangomgqibelo kusukela ligamanxe ihora lesi-8, 8:30, kuze kugamanxe ihora lokuqala emini, 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi Go Digital SA_movement noma kwi-YouTube uthi Go Digital SA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni ke lolu hlelo, nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani grade 12 namhlanje sikhuluma ngetopic yokugcina physics photoelectric effects that's paper 1 yona itopic nje yokugcina and umbuzo wokugcina futhi kwi-final exam moni paper lakho nje le-final exam photoelectric effect is the last question. Photoelectric effects it deals with light. Right? Now, light has a dual nature. Right? Light can behave as a wave, from grade 10, but light can also behave as a particle. Can behave as a particle. When it behaves as a wave, light falls under electromagnetic radiation. Electromagnetic radiation or radio wave, microwave, infrared, visible light, visible light, ultra infrared, visible light, ultraviolet, X-ray, and gamma rays. Right? So visible light fall under electromagnetic radiation and galas light. So because we have that one, so it falls under a certain range frequencies, the visible light. So skulumanga light and as light, we know the speed of the electromagnetic waves in a vacuum, and so we can see that is equal to 3 times 10 to the power 8 meters per second. Let's not forget that. Right, the speed of light. So it has speed of light has 3 times 10 to the power 8 meters per second. Right, now let's remember that. If light is a wave, it means a wonk properties a wave are being observed here. As it's a wave in a wavelength, it has a speed it has a frequency, it has a period, it has amplitude, and so on, right? Sakumbula a graph, a wave like a transverse wave, for example, right? From this point to this point. Now, kia depend ukuthi unikezweni ngala. If you have delta t, this point is the same as this one. It happens at the same time, on the same position. So this point to this one are, the 2 points are in phase. So there are 2 consecutive points in phase. Ngoba x-axis u delta t, so the lesikhathi leso kusuka from one point to the next point in phase sibiza ngani nge-period. That one is a period, right? Then if you have a graph where x-axis is distance, because what is distance, then you have your graph ehamba kanje, then you know ukuthi from this point to that point you can calculate what that distance. That distance, it does no longer represent what in a period ngoba sikhuluma nge-distance. So this time it represents what? A wavelength. So you have a wavelength. So if I uqaphele njalo uma unikezwe igraph ukuthi what does the distance between the 2 consecutive points represent? Uma ukuthi kuma x-axis you have delta t isikhathi, kusho ukuthi that one represent a period. Uma ukuthi it's a distance, that's a one cycle for the wave, that represent what? A wavelength. So you have to remember that. Okunye siyazi ukuthi ngoba sine period, sine frequency, sine wavelength, sine speed, kodwa manje ngoba sikhuluma ngani nge-light, speed sakhona siyasazi. So we are writing bani c, right? Sinani sine amplitude futhi. Amplitude, you are looking at the maximum displacement from the rest position, the amplitude. So we have that one. Kusho ukuthi all the calculation, the wave equation, siyawazi wave equation, you have v, the speed is equal to frequency times lambda. Now in our case ngoba sikhuluma nge-light, asobhala ukuthi v, so now bani c is equal to frequency times wavelength. So from this one siyakwazi ukukhipha any other formula from there, uyakwazi ukuderive or make what frequency abe a subject of the formula. Mhlambe sothi f is c over lambda, noma sothi lambda as a wavelength is c over frequency, and so on, right? So we have to remember that. Mase kuba khona a relationship between a frequency and a period. Remember, by definition, a frequency, it will be the number of complete wave passing a point in 1 second. A period is just what the time that will take for a wave to complete, a full wave to complete. So a relationship with a frequency is equal to 1 over t, the inverse of the period. And a period, it is in second. So with the unit for a frequency ubani per second. It is a per second, right? Lo per second simbiza ngani ko hertz. So the unit of frequency is the hertz, and 1 hertz is 1 per second, right? So ngoba sikhuluma nge-wave, so these are the properties of a wave. And because this one is a visible light, one of the electromagnetic waves, we know the speed. So that speed is 3 times 10 to the power 8 meters per second. Right, now what is the next thing we need to understand? Light as a wave, but the same light yakwazi ukubehave as a particle, right? Light as a particle. Mostly a particle ka grade 10 sakwenza futhi light as a particle. It means it contains what certain packet of energy. So ebiza ngani gama photons. Photons. This is a packet of energy contained in light. Noma sibiza a quantum of energy. Quantum or packet of energy found in light. Right, so it means a light carries what? A certain amount of energy found in light. So because we have that, this is the particle nature of light. Ngoba sina leyo energy kusho ukuthi siyakwazi ukalculate leyo energy. So ibiza ngani E. The energy it calculated as H times F. E, it is the energy that is expressed in joules. Sinani sino F. F is the frequency of the light. The frequency of the light in hertz. Remember, 1 hertz is also 1 per second. Then you have H. H is the Planck's constant. Planck's constant. Wale formula kamuga no Planck's, so bizangani ngo Planck's constant. Mawubuka nje i-formula kanti uzabona ukuthi masenza le Planck's constant abe the subject of the formula. So to H uzoba bani E over F. E unit ka E ubani joules. E unit ka manga frequency it's a hertz. Kodwa siyazi ukuthi a hertz is 1 per second. So kusho ukuthi ngala sinobani per second. So at the end sinobani joule second. So E unit Planck's constant it is the joules second. Right? And the value yakona, because it is a constant, 6,63 times 10 to the power negative 34. This will be given joule second. If value Planck's constant. Kataje masibuka nje le formula ezoti E is equal to H times F. Ngoba lo H is a constant. So kuti yona ishinji means what? E energy so itolangala directly depend on the frequency. So the higher the frequency, the higher the energy contained in that particular light. Right, so let's not forget about these few things. Then, njengoba energy kanje, frequency is also given. Masibuyela kuma formula akhona siyazi ukuthi frequency can also be calculated as speed over wavelength. So this formula we can expand it so to, instead of writing F sungatibani C over lambda. It's the same formula ngoba siyazi ukuthi from C is equal to frequency times lambda. So if frequency siyakwazi uyithola in that way. So masinikezwe mhlambe I wavelength mase kuthiwa calculate the energy. So velocity Planck's constant times C. You see it's also a constant. Yabona nje kwi formula eyodwa sinama constant awu2. This one and that one. That ngoba this one we know is 3 times 10 to the power 8. This one we know is 6,63 times 10 to the power negative 34. Right, so those are the basics of a photoelectric effect. Now, what is a photoelectric effect on its own? So this one is a phenomenon or a process. It is a process, a photoelectric effect. Right. Photoelectric effect. It is a process. I want that part. A process. Kuna stages. Right? Photoelectric, a process. Process, we understand stages. Process where electrons are emitted, where electrons are emitted or emitted, right, from a metal surface. From a metal surface when a light of suitable frequency shines on it. So what are we saying, Uguti? If a light shines on a metal, right, any metal, and it has a greater amount of energy, then electrons will be released from that particular metal, right? So, a process means what? There must be a light that is shining. That light, it behaves as a particle. It contains what? Quantum of energy. So we can calculate the energy contained in that particular charge. Then it shines on a metal. A metal has electrons. Now the electrons are connected or are bonded to what? To nuclei, the protons, But when those electrons will absorb little energy from the light, they get excited. Once they get excited, they move away from the protons or the nuclei. Now, once they move away, they get almost free. Now, if they get more energy, those electrons can be ejected. Right? Let me try to make a certain illustration of what I'm saying. Now, it's a metal. Right? Then we have protons. Then we have the localized electrons. Sinama electrons. And we have electrons right around that as a metal. Now what will happen is that a light will shine on this one. This is an incident light. We know that the light go in a frequency, it is then because of the frequency, this light, there are photons that are shining on this metal. Because we have photons, we have energy, so we can calculate that energy. Moguti has a frequency of light, we can find energy. So it means what? When the light shines on this metal, there is energy. Then lama electrons lawa azo absorber leyo energy. Once they get the energy absorbed, azo zangala, they are moving away from protons from the nuclei. So my electrons are now on the surface of the metal. They are no longer connected or attracted ku nucleus akon. Now, because you have that, electrons lawa, they are almost free. Adinga ukuthi athole extra energy ukuze enze njani asuke la kwi metal, so they can be what? Ejected. Right? They can be ejected. Now siyabona uma uthi ejected kuzo ayamuva, and moving means what? Sikhuluma ngani nge-energy. Khona ini sibiza ngani nge-kinetic energy. So dinga bani i-kinetic energy ukuze lama electrons asuke kule metal ahambe, as we are saying they are emitted. Right? So that is the whole process. The incident light comes in. It comes with a certain amount of energy. Then you have electrons in the metal. So it always depends like how electrons are connected, bonded to nuclei, to the nuclei of the metal. All metals are not the same. Mhlawumbe sodium and magnesium, noma iron or cesium. Uyabona ukuthi as there are different types of metals, they have also different ways of holding on to electrons. Right? So kusho ukuthi le energy ezofika la ifanele ibe inkulu ku energy ebamba electrons next to their nuclei. So mawuthi inkulu, then means what? Makuthi yalingana, it will remove lama electrons iwasuse ngala ku nucleus olethe la ku surface of the metal. Right? But le energy mayinkulu kakhulu kusho ukuthi there will be an extra energy kuma electrons. Leyo extra energy izokwenza ukuthi electrons enze njani asuke la kwi metal. Then we have what? A photoelectric effect. But mawuthi light that shines on the metal does not have energy enkulu. Kusho ukuthi lama electrons also absorb energy, and then nothing is happening. There won't be any electron that will be ejected. Ngoba le energy efigayo is not enough to remove or to detach electrons to their nuclei. Right? But if ungenzeka mhlambe energy efika ifana ne-energy ebamba lama electrons next to their nuclei, then uzobona ukuthi lama electrons azosuka lana kodwa azosala kwi metal, they will be on the surface, azoba la phezulu manje, almost on the edge of this metal or this metal. Right? Now mawukuthi uzofaka more energy, at that point electrons are ejected. So still we don't have what? A photoelectric effect. But most of an excess energy, most extra energy, leo extra energy lama electrons azothola leo extra energy, iyona energy izokwenza ukuthi lama electrons enza njani anyakaze asuke from the metal. In that case khuluma ngani nge-photoelectric effect. Remember, because it is a process, three things must happen. So we have three stages. Now, sikhuluma ngama electrons being emitted, right, or ejected. This is the final, right, the end product. To be emitted, there is what? A kinetic energy, to be emitted. Kusho ukuthi lama electrons azosuka. That is the end stage from a metal surface, right? We are talking about a metal when a suitable frequency, a light of a suitable frequency. Must be suitable, sikhuluma nge-energy ezokwazi ukususa lama electrons next to their nuclei iwalethe la on the surface of the metal, right? Lokhu kwenzeka ku stage 2, right? This one was stage 3. When frequency when light shines on it, when it shines on it, that is the incident light. That is the first stage of this process. So kule process zakhuluma ukuthi there is stage 1. Stage 1 is the incident light. Stage 2 fanele senze njani si overcome le energy ebamba ama electrons to their nuclei. Leo energy ebamba ama electrons to their nuclei sibiza nge work function. Sibiza nge work function. Each metal in a work function yakhona. It is an amount of energy that is needed. Right? So we have a work function. That is the energy of that the metal need ukuze lama electrons abe asuke ku nucleus ahambe gephi abe kwi surface of the metal. Then sidinga extra energy ukuze lama electrons enze njani akwazi ukuphuma abe emitted from the metal surface. Now let's just give an example. Let's say mhlambe le metal inobani I-work function yakhe ubani u70 joules. Just an example, right? Sino 70 joules, right? So udinga u70 joules ukuze i-relationship between these positive nucleus and the electron to be broken, right? So udinga u70 joules. That becomes your work function. So kia depend what is the light that comes in. Yona ifika ne energy engakanani. If ifika ne energy mhlambe 50 joules, angisho lo 50 joules is not enough ukuze ukuthi asuse le electron next to the nucleus. So akwenzeka lutho, the energy will just be absorbed by the metal. What if i-energy engenayo mhlambe ifika ibe no 70 joules? Angisho ukuthi kuyalingana ke manje at that point. Right? Njengoba zokulingana, still the electrons will just be detached from a nucleus yakhe, then but is still on the metal. Right? So in that case, no electron is emitted. As long as there is no electron that is emitted, asikhulumi nge-photoelectric effect. Photoelectric effect yenzeka makuthi kunama electrons that will be removed or that will be emitted. Right? Now the next example is, what if sifaka mhlambe energy light ifika ne energy 100 joules. Angisho lo 100 joules, so thatha u70 from this 100 ukuthi lo 70 uzo overcome le energy le ibambisa le energy le electron ku nucleus ya the 70. Then beside lo 70 still no extra kabani ka 30 joules. Ilo extra ka 30 joules that will be converted into kinetic energy. Now kusho ukuthi lama electrons se azohamba manje ne energy kabani ka 30 joules. But the light that came in kade ine energy kabani ka 100. Then ifanele lo 100 overcome in work function u 70 joules. So kulo 100 siyakwazi ukuthola u70 bese kuba khona ni extra kabani ka 30. So this means we can write equation so sino 100, but kulo 100 fanele start to 70 simsebenzise as to get to break or to overcome this energy between the nucleus and the electron. Mese siba nalo extra ka 30. Ilo extra ka 30 uzophenduka ini kinetic energy. This one doesn't change. Kusho ukuthi mashinja le energy mhlambe i-light isebenzise i-light ino 120 joules. So sizoba nobani no 120 ngala. Kulo 120 sidinga u70. Still u7 ngoba awushintshanga, the metal did not change. Sadinga nje u70 ukuze ama electrons asuke kwi nucleus aye nje kwi surface of the metal. I extra bethu manje seku 30 manje seku 50. So uyabona ukuthi on this second case ama-electrons azosuka ne-speed esikhulu ngoba i-kinetic energy siyazi ukuthi ithi half mv squared, right? So i-speed kule second case sama-electrons sizoba esikhulu as compared to the previous one. So that is the process, and that's all as for a photoelectric effect. If you understand that, then nothing will be a problem, right? Now asibuke a situation where sikhuluma light that is incident light, that is process 1 or stage 1 of the photoelectric effect. Sikhuluma light. That light inani inama-photons. Ama-photons contains what? Ama-particles, ama-packet of energy. So kusho kuthini on that light siyakwazi ukalculate bani? On stage 1 siyakwazi ukalculate energy ngoba siyazi frequency. So the h, we know ukuthi h is the Planck's constant times frequency. Or stage 1 sinaloko. Then we can work around anything else esifunayo. Mhlambe sizothi energy is h times c over lambda. Lokhu kusenzeka kephi ku stage 1 ngoba sikhuluma light efikayo, right? Then stage 2. Stage 2 yenzeka within the metal. Ilapho ke le energy ezofika ne-light ifanele i-overcome le energy ebamba ama-electrons ku nuclei, kuma nuclei yakhona. So we have stage 2. Ku stage 2 leyo energy ebamba ama-electrons on their nuclei sibiza ngani work function. I-work function is also what? Energy. So ibiza ngani W naught. Now by definition the work function is the minimum amount of energy required for an electron to be ejected. Remember from our example, our work function was 70. So as long as our figure was 70, nothing will happen. So it's the minimum energy that is required. So go back with energy. The work function is the energy. Then it says ukuthi masikhuluma light, masikhuluma energy, sithatha a Planck's constant times what? A frequency. This simply means that the work function nayo singayithola in terms of a frequency. So to h times a frequency. Leyo frequency sobiza ubani f naught. Ile frequency zoskiphela le energy efana nani ne work function. So le frequency lezokiphela energy efana work function sibiza ngani threshold frequency. Sibiza threshold frequency. Noma sibiza ngani cutoff. It is a cutoff frequency. You have a cutoff frequency. Now, sitei work function is the minimum energy required for an electron to be emitted from the metal surface. Ngoba le work function vele yenziwa le frequency. Kusho ukuthi ne cutoff frequency is also the minimum frequency required for an electron to be ejected from the metal surface. Because we have a frequency, siyazi ukuthi a frequency now is related to work to wavelength. So the same formula here singayibhala ukuthi W naught is equal to h times c ngoba sikhuluma light over lambda naught. Lambda naught will be what? Our threshold wavelength or my cutoff wavelength. So in wavelength, the cutoff wavelength now, it's a minimum wavelength that is required for the electrons to be emitted from the metal surface. So we have on stage 1. Nanga formula singawasebenzisa. Anything under stage 1, bangakubuza calculate the energy of the incident light, noma a frequency of the incident light, noma a wavelength incident light. Ngala ku stage 2. Ku stage 2, bangakubuza to calculate what is the work function, noma calculate what is the cutoff frequency, noma calculate the cutoff wavelength. In terms of AMA definitions, ngala ku stage 1, actually to define what is a photon, for example. Right? Noma kutiwa define what is the photoelectric effect. Ngala actually to define what is the work function, noma define what is the threshold frequency. Right? Noma define what is the threshold wavelength. Then stage 3. Stage 3 ilapho ke kusuka ama-electrons. Remember lama electrons azohamba as only if frequency engenayo ine-energy enkulu kule work function. So if the energy engenayo that shines on the metal inkulu kune-energy ebamba ama-electrons lesibiza ngani nge-work function, then leyo extra leyo iyona iyona izosebenzisa for ama-electrons ukuthi akwazi move away from the metal, right? So stage 3. With stage 3, what do we have? With stage 3 sikhuluma ngama-electrons ahambayo, and if they are moving so sine kinetic energy. Sikhuluma nge-maximum kinetic energy. Into siyazi ucalculate ukuthi i-kinetic energy ayishinji as a formula, it's half mv squared. So bangakutshela ukuthi ucalculate mhlambe i-kinetic energy yama-electrons noma ucalculate i-speed calculate speed sama electrons. This m is the mass of electrons. The mass of an electron is what? As 9,11 times 10 to the power negative 31 kg. That is the mass of an electron. Right? It's also a constant. Uyabona ukuthi kule process maningi ama-constant. Ngoba masiku stage 1, u-H is a constant, u-C is the constant. Masizangala ku stage 2, sine Planck's constant, also what? A constant. Nalo C also a constant. Masiza stage 3, the mass of an electron is also what? A constant. Maninga ma constant kule photoelectric kule process. So you have to check ukuthi in leo nikezo yona, cause on this side sema akutshela ukuthi calculate the kinetic energy of the electrons, calculate the speed of the electrons. Lama electrons lawo asusiwe kwi-metal siwabiza ngani ngama photoelectrons. Siwabiza nge photoelectrons. Ama photoelectrons. Right? Ama photoelectrons. So that is the principle of a photoelectric effect. So we can put this formula together. So go to stage 1. Stage 1 ufika nani? Ne total energy. Stage 2 uzobamba le energy oyidingayo. The rest of the energy izosebenzisa kephi? Izosebenza ku stage 3. So what will make the photoelectric effect to happen? It depends on what? The first thing uthi energy, the light that comes in energy engakanani. The second thing izo depend ukuthi stage 2 the metal idinga energy engakanani. That energy doesn't change for a metal. Let's say sikhuluma mhlambe sodium as a metal. Makuthi the work function of sodium is 5 times 10 to the power negative, let's say negative 15 joules. That work function doesn't change. It doesn't change to remain constant. So any light that will shine kule metal, if finally overcome lo 5 times 10 to the power negative. Any extra izosebenza ngala ku kinetic energy. So kinetic energy yona can change. So if we put together lama energy, uyabona ukuthi sidinga energy ezongena, sidinga energy to be overcome, sidinga energy ezokhipha ama electrons. That will make the electrons to move. So in another word, sizothi ukuthi energy of the incident light is equal to the minimum energy required for electrons to be ejected from the metal, esibiza ngani nge work function, plus kinetic energy yama electrons. Right? That is the formula that we have for photoelectric effect. So stage 1, stage 2 lo, stage 3. So this energy here must be enough ukuze i-overcome lokhu, then kube nani kunelo EK maximum. So if we have to compare these two, makuthi energy of the incident light is less than AW naught. This simply means that EK maximum is 0. And if it's 0 means what? No photoelectric effect. Akukho nje photoelectric effect oyenze. Because by photoelectric effect, sikhuluma ngama electrons that will be ejected. No photoelectric effect ezokwenzeka because the energy of the incident light, the light that is shining, it's not suitable. Remember quick definition, of a suitable frequency. Sikhuluma nge-suitable frequency ngoba sifuna le frequency izofika isinike i-energy ezoba enkulu kunani ku-work function. So if the energy that comes in is equal to W naught, let's say i-work function u-70, sifaka ne-work function i-energy engenayo u-70, angisho about i-K usawu-0. So as e-K maximum is still 0, it means no electron is ejected. So if no electron is not ejected, means what? No photoelectric effect. No photoelectric effect takes place. So the only time the photoelectric effect will occur is only when the energy engenayo inkulu kune energy ezodingeka ukuthi imove ama-electrons. Now at this time kinetic energy yetu is greater than 0. Then at this point there is a photoelectric effect. Photoelectric effect will take place now because the energy of the incident light is greater than the work function. Right? I hope you understand that. Now, kumbuzo, they will always give you a few things. This one, this topic, ilula kuyithola ngoba every time mabakuniga information ehambisana ne stage 1, bakutshela about the light, mhlambe bazokunika i-wavelength, bakunike noma i-frequency noma i-energy. Then mabakunika information la u-stage 3, bakutshele mhlambe i-kinetic energy of electron, kusho ukuthi umbuzo uzoba about stage 2. Mhlambe bazokutshela ukuthi calculate the work function of the metal noma calculate the threshold frequency of the metal. Or sometimes bavele bakunike i-work function, baphinde bakunike nani ne-speed of ama-electrons. Angisho bonke bakunika into from stage 2 no stage 3. Kusho ukuthi umbuzo uzoba about what? Stage 1. It's always like that. Kodwa ke still under stage 2 they can ask you few things. Mhlawumbe bakunika i-work function, they can tell you to calculate what is the threshold frequency, or they can tell you to define what is the work function or what is the threshold frequency, right? No mangala bakunika mhlambe speed sama electrons, so they still can ask you to calculate what is the kinetic energy of those electrons, right? And then if unikezwe lokhu, then bazokubuza umbuzo uzoba ku stage 1. Ku stage 1, that is the incident light. Bakubuza ukuthi mhlambe calculate or noma define what is a photon, or calculate the frequency of the incident light, or calculate the wavelength of the incident light, right? So that's how easy this topic is. It's so simple. Then sikhuluma ngama-electrons akhishwayo kuyilokhuzana kuyi-metal. Lama electrons asifuna ukuwaluza, so we can make sure that we channel them very well ukuze azosiza on something else, right? Now njengoba asuka kwi-metal, now we can have a setup ezoba, let's say usine setup enye that is mhlambe i-metal. We have a metal, we connect it somewhere, right? Ngoba asifuna ukuluza lama electrons, senze kanje, right? Then now what will happen is i-electron, i-light izoshine kule metal. It will shine on this metal. Now as it shines on this metal will do what? Will release ama electrons, right? If this light that shines here has a suitable frequency, a frequency greater than the work function of this metal, ama electrons are released. Now ama electrons are on a direction. Now how do we get a direction yama electrons? So bona ukuthi kule part lena senze njani, singa connector ini, as connect khona i-battery. As connect i-battery, right? If we connect a battery, i-battery u-positive, angithi uyabona ke manje kulana seku-positive, ama electrons are negatively charged. What will happen? Ama electrons azoza ngala, right? Ama electrons azoza ngala. Then asifake ammeter ngala, then we can see what will happen, right? Ngoba this part is a positive, ngoba is connected with positive ye battery, ama electrons will be attracted. Lama electrons azohamba ke ngala. Yabona ama electrons ahamba kephi kwi-metal. This is a flow of ama electrons. And the flow of electron in a conductor sibiza ngani? Sibiza nge-current. Now this is another source of electrical energy. Ngoba iphuma ngala sibiza ngani? Lento sibiza nge-photocell. This one is a photocell. It has produced what? An electrical energy. Right. So we have this light energy that shines on this metal. Then our electrons are ejected. Now this electron to be ejected, we are trying kwafakuti ahambe in a conductor. Go back on a positive, it connected to a positive charge. So as our electrons are hamba kule conductor, that is a flow of electrons. And the flow of electrons, we call it what? A current. So sina a current. So we have a cell. We produce what? A source of electrical energy. This is the phenomenon used for solar panel. A solar panel is the same. This is the principle that is used. When the sun shines on your solar panel, electrons will be released from that metal. Then those electrons will pass through a conductor to give you what? A current. Right. Now, this will only happen Maguti, the light that shines has a greater frequency. Now, Masinele photocell, let's look at the impact of the light. Now, if we want to describe a light, there are two factors that we can look at as for a light. The first thing, when you have a light can have what? A frequency. So we can differentiate them in terms of frequency. Remember, in terms of ama colors, right? In terms of colors, kabang sakumbula o roy, GBF, red, orange, yellow, green, blue, indigo, and violet. So as you are moving from red to violet, there is an increase, right? Increasing frequency. And as you got a frequency and a wavelength, they are inversely proportional. This simply means there is a decreasing in wavelength. Decreasing wavelength. As you suga from red to violet, right? There is a decrease in the wavelength. For to remember, so the energy on the light depend on what? With frequency. So you are going shine a green light. Depending shine an orange light, a green light in a frequency and kulukshuti green will give us what? A higher energy as compared to orange. So we can play around in a frequency. So if we are not playing with a frequency, kungaba hlambe a green light, but one green light ekanya kakulu or compared to the other one. So skulumangani get intensity. Skulumanga intensity of the light. But if frequency remains the same, right? The only thing is kulumangayo, it is the intensity. So maskulumanga intensity as kuluminge frequency. Maskulumanga frequency as kuluminge intensity. The frequency will depend on the colors. You are changing ama colors, right? Sevensu blue, no pindu sevensu red. You want to blue une frequency and kuno red. It means what? Looking at this formula, the one with the greater frequency will give you what? A greater energy, right? So you can compare those colors in that manner. But into CS Yuguti, because we have that higher frequency and we have greater energy, so we now need to look at what if we have some blue light. The first blue light ikanya cool as compared to the other, but because it's blue, so got a frequency I shinjang. That means what? Energy is still the same. But sinani sine intensity. Intensity mokanya akulu means what? Ama electrons ama ningi will be what? Will be affected. Now, how will this affect a ammeter reading? Now, how will this affect ama photo electrons? Umasi increase a frequency. Masi increase a frequency. Ama electrons azo sugalana from the same formula. As yoguti A is W naught plus plus EK, maximum EK, right? This one, it is H times F. So when you are increasing the frequency, you are increasing what? Energy. Lokhu kuhlezi ku constant. Akushinji. This one is constant. So because it is constant, maku increase energy, ku increase nani? Ne kinetic energy. Right? Because this part here, your work function is constant. It doesn't depend on the light that is shining on the metal. But kinetic energy, it is affected. So when you increase the frequency, let's say we're using a red light, say red light, blue light. The blue has a higher frequency. So ama electrons mase sugalana because the kinetic energy has increased, and from this siyazukuthi kinetic energy is half mv squared. So if sifuna ukwenza a speed, the subject of the formula, so that will be the square root of what? 2ek over m, right? So in that case, if you increase the kinetic energy, if the kinetic energy increases, the speed here increase, and vice versa. So if you increase the speed, the energy, the kinetic energy will also increase. So you have what? A constant. Maku increase a frequency, we increase an energy. Maku increase a energy incident light, we increase an kinetic energy, and must increase a kinetic energy, we increase the speed sama electrons. Then you have that one. Kushoguti a meter reading yona aizoshinja ngoba. Remember current skulumange, current is charge per unit time. It talks about the number of electrons passing a point in 1 second, right? So the only thing here is more increase the frequency. Ama electrons are having speed school, but they still what? The same number of electrons per unit time. Just that make lula lapo on that particular point, but having speed the school as compared to if now we are increasing intensity. Masi increase intensity, the formula I affected in club on this one. More increase intensity, energy is a iona. If this energy remains constant, the work function is constant. Shoguti ne kinetic energy will remain constant. If you increase intensity, there is no effect kule formula. The formula affect a frequency. Because if we break it down, so to HF, I'm sorry, frequency angena ngala. Lana so to H times F naught, frequency angena 40. But this one is always constant. Plus bani half mv squared. So the only factor that will affect the formula is the frequency. It can be frequency, no mas kulumange wavelength, ngoba siyazi ukuthi wavelength is related to frequency, no mas ngakulumange period, ngoba siyazi ukuthi period is related to a frequency. So the only factor that will affect this one is the frequency. And mas kulumange frequency is kulumangani nge speed, the speed of ama electrons. As kulumange number of electrons, but maso increase intensity. Intensity does not affect the speed. Kota njengoba si increase intensity kushoguti izo cover spaces cool on the metal. My cover spaces cool means more electrons will be affected. Masina more electrons kushoguti ama electrons amaningi azo suga with metal. So if we have too many electrons, sibuye langala. So the number of electrons has increased. If the number of electrons has increased, means the current is increased. So the ammeter reading will also increase. So the only factor that will affect the ammeter reading kule photo cell yetu is the intensity. Otherwise, more sebenzisa a frequency, no change will happen in terms of the ammeter reading. The ammeter reading will remain constant, but it will only change if we increase by intensity. Normally it will decrease our mass, it decreases intensity. So intensity has nothing to do on the formula, but it has something to do with the number of electrons. So ngamanye sifuna ukusummarize sotini maskuluma nge intensity. So intensity affect what? Number of photo electrons. Number of photoelectrons. If number of photoelectrons means what? Current. Current is affected. Current most of the time bazokutshela ngani nge-ammeter reading. It is affected. But masikhuluma nge-frequency. Masikhuluma nge-frequency. I-frequency ihamba ngani? Speed of photoelectrons. So frequency ihambisana ne-speed sama photoelectrons. Current, no, it's not affected. Current constant. Current is constant. And ngala singathi ukuthi uma kuna intensity formula, the formula le W naught plus EK, not affected. Not affected. Right, but ngalana, this formula here, W naught plus EK, it is affected. And makuthi affected ngoba i-photoelectric effect vele khuluma ngokuthi the electrons will move. Then sikhuluma ngani nge-speed, nge-kinetic energy. Masikhuluma nge-kinetic energy, sikhuluma nge-speed. So that's how it always works. Masikhuluma nge-photoelectric effect. So that is how it works. Asibone ukuthi sibalo esisodwa nje before we look at what we have. Right, now let's say sinikezwe i-intensity light of energy 5.6 times 10 to the power negative 19 joules is incident. Yabona ke masikuthi was incident on a metal. Makuthiwa incident sesinani is stage 1 on a metal of threshold frequency equal to 7.2 times 10 to the power 14 hertz. Right, now before I even ask some questions, so nigezwe bani energy, the energy of the incident light. Stage bando, stage 1. Stage 1. Sazi in your stage 1. Sazi go to E is H times F. Sazi go to E is H times C over lambda. Right? Sazi go to what is a photon? Siyakwazi to explain na yonke. So umbuzo ungaba lapho, they can ask you about into ihambisana nani nale incident light. Kusawubani ku stage 1. Right? So on this one mhlambe kungathiwa calculate what is the frequency, right, of the incident light. Angithi unikezwe energy, so yakwazi ukuthola from this formula. Right? Kuthiwa it is incident on a metal of threshold frequency. Le part lena ubani u stage 2. Stage 2. Njengoba kuna stage 2, what do we know about stage 2? Go stage 2 excuse. Go stage 2 siyazi ukuthi sinani sine work function. Kusho ukuthi bangakutshela ukuthi define what is the work function under stage 2. Ngathiwa define what ngoba kunikezwe threshold frequency, bakunika ukuthi define what is threshold frequency, cutoff frequency, right? Noma bangakutshela ukuthi ngoba unikezwe work threshold frequency, ngathiwa calculate what is the work function. Angisiyobona ukufalla under stage 2 work function. I-work function siyazi it H times what? F naught. F naught not is straight threshold frequency. So they can ask you any of these questions, right? Then njengoba unikezwe stage 1 or stage 2, the other question obviously izofika kepi u stage 3. So any question izoqhamuka manje izoba on stage 3 because you are not given anything on stage 3. What do we know about stage 3? Stage 3 siyakwazi kune kinetic energy. Siyazi kunani kune speed. So i-formula zoti EK maximum is equal to half mv squared. So the question they'll ask you here is either calculate what is the kinetic energy of the electrons, noma calculate the speed of the electrons. Abazokubuza ngalo ngoba this one is the the mass, it is a constant, right? Yeah. Then the last thing we can talk about is a graph. Sometimes you are getting a graph, a frequency ngala, une kinetic energy ngala. Kinetic energy of the particles. Now, ma increase a frequency, uzobona ukuthi on this formula, ukasiphalela no O E is W naught plus EK maximum. Low E is H times F. So every time must increase le part ifane size sifike ku W naught ukuze kube ne kinetic energy. So when you are increasing from 0, right, kinetic energy is 0, because we still have what a frequency that is less than the threshold frequency. Must figure la at this point mhlambe iyalingana I frequency of the light, right, ilingana nani ne threshold frequency. So every time masidlula lapho ke sobona ukuthi I graph isizonyuka as we increase I frequency. As we increase the frequency means we increase the energy. Ngoba I work function is constant, kuya increase abani I kinetic energy. So you have a graph ezongena ngala. So it does not start at 0. This point here, ngoba hamsana no frequency. This is the threshold frequency. Mawuthi ungathatha enye metal nayo uze udwebe ngala izokunika something na. But these two lines will be parallel. Mawubuka the gradient of this graph. I gradient yale graph ikunika bani? Ikunika angisu energy ngala. So the frequency izokunika into change in energy over change in frequency. And that is the joules second. And joules second is what is the Planck's constant. Gradient ya corner is the Planck's constant. Mawuthi uzoenza extrapolation uzothi kanje uzofike la, right, on the y-axis. This part here ikunika bani? Ikunika I work function, right? So if you understand the graph, then makuthiwa unikezwe graph kuthiwa calculate get the work function, just extrapolate nathi work function uyakwazi ukuread from this graph. I gradient yakhona you can use it izokunika bani? Planck's constant. That's all as for paper 1 and photoelectric effects. Siyathemba ukuthi nifundile and siyabonga. So monana next time.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje enisethulelwe ngezidlokotho ezinhle Ithala libambisene neGo Digital SA Foundation. Thamelani ke futhi esilandelayo ngesikhathi sifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.